Our last topic in elasticities is the topic of price elasticity of supply. Just like everything else we've looked at, it's saying how responsive is supply or quantity supplied to a change in price. Keep in mind, this is going to be the mirror image of price elasticity of demand. So just like when we looked at demand, we were looking at a change in quantity supplied along with a change in price. Since we're changing both price and quantity supplied, that means we're talking about movement along the existing supply curve. So really, we're just further investigating the law of supply. We're not going to see a shift in what we're looking at here, only looking at different parts of the same supply curve. Our formula, it's going to be the exact same as what we saw for PED, except of course, instead of percent change of quantity demanded, it's going to be percent change of quantity supplied. I want to start off talking down here because PES, there's actually a real helpful, simple way that we can always look at PES and always know exactly what our values are going to be. So, when PES is greater than 1, and we would talk about this being elastic supply or price elastic supply, what's going to happen is for all three of these curves, even though they're, S1 is more shallow, it's less steep than S2 and S3 are. Even though they have varying steepness, their slopes are different, it doesn't matter. Because they all come from they all start on the y-axis, because of that, these are all going to be, the results of all of this is going to be the PES values are going to be greater than 1. We'll see that change along the length of the curve, i.e. going from one point to another point would be different than going from a third point to a fourth point. But every value you will ever get on any of these curves, as long as they start from the y-axis, is going to be greater than 1. Let's see why that's true. What we need to remember, and for HL students, you should connect this, that when this is true, when it's coming from the y-axis, what that means is that the C variable is negative. Well, so I've got 3 examples here. So I'm using the same C variable for each, and I'm changing the slope from 0.5 to 1 to 2, and that would be producing 0.5 would be the blue one, 1 would be that one, and 2p would be S1, for example. Obviously, this isn't hyper accurate over here, it's just a sketch. So, what we should see, let's go ahead and look at, we're going to take a price change from 10 to 20 and plug it into our 3 formulas. By the way, I'm going to repeat this 3 times, or I'm going to repeat this, this process 2 more times. So, we'll go a little bit faster in the next 2, but this one I'll take it slow. So we're going from 10 to 20, and all I did was put price into the various formulas. So I said a price of 10, QS equals -5 plus half of 10. Half of 10 is 5, so 5 and -5 is 0. And then I plugged in 20 and I got 5. I did the same with Q2 and Q3. If you don't believe me, you can put it on pause and check my math, but I'm pretty sure I'm right. Okay? So what we end up getting is with the same price change from 10 to 20, so increasing price, of course, quantity supplied is going to go up because we're talking about the law of supply. But what we see is that we get a change of supply of 5 in the first one, 10 in the second one, 5 to 15, and then 20 in the third one. And again, 5 is half of the price, 10 was the same as the price, and then 20 is twice the price. So again, we ought to see that coefficient of P, we ought to see what it's doing in our results down here. For my formula for PED this time, I'm going to use the change in Q, so 0 to 5, or 5 to 15, or 15 to 35. I'm going to use the change in Q over the average of Q. Remember, this is the midpoint formula that we looked at a little bit ago. It's just a different way of doing PED, that's all. So using the midpoint formula, the change in price is a change of 10 over the average of price is 10 and 20 is 30 divided by 2 is 15. So it's 10 over 15, so our price change for all 3 of these examples is going to be 66.67%. Let's go ahead and look at, in blue, let's look at this 200% change we see here. Now, again, remember that because we're using the midpoint formula, we get something a little bit different. So for example, we went from Q1 of 0 to of quantity 0 to quantity 5. Well, that's greater than 100% change. That's like an infinite change. We went from 0 to 5, well, that's a really big percent change. It's another reason the midpoint formula is useful here, because I can just, again, do change of quantity, which is 5, divided by the average quantity, which is 0 plus 5 is 5, divided by 2, so 2.5. So we're saying 5 over 2.5 is 2, which equals 200%. So what we're looking at here, and again, you can check my math on the other two, but what you see in each one of these is that the result is bigger than 66.67. So what we have, again, looking at this number over that number, we have a bigger number over a smaller number. This is always going to produce a result of greater than 1, which gets us back to what we said here, that no matter what, and you can test this theory as many times as you like, no matter what, if we're starting from the y-axis, PES will be greater than 1. Moving on, if it comes from the origin, and I maybe didn't draw those perfectly, but those are all starting at the corner, okay? If it comes from the origin, the PES will always be equal to exactly 1 for the whole length of the curve. On this, we'll still see the PES value change as we move out, but it will always be positive, or I'm sorry, always be greater than 1. No matter what, the PES will be 1 at any point along any of these curves. It doesn't matter that they're angled differently. I can show this to you mathematically if you'd like. We've gotten rid of C. There is no C variable, it's 0. And I have the exact same slopes, 0.5p, 1p, and 2p. Again, I've plugged those numbers in down here. You can check my math there if you would like. And I'm going to use a different calculation for PED this time, and I'll explain this in class eventually. But a different calculation for PED is the slope of the curve times the price divided by the quantity. So now let's look. So I've done that in blue over here. So the slope of this curve is 0.5. The price over the quantity is price 10 with quantity 5. So this is 0.5 times 2, which equals 1. Or if I look at the new price, the price after the change, it's price 20 over quantity 10. So again, that's going to be 2. So 0.5 times 2 is still 1. And again, you'll notice that would continue to happen as long as we go, because of the coefficient, basically the price is always going to be twice as big as the quantity. So again, they just have to cancel each other out. I'm sure mathematically one of you can prove this in a better way than I can. For the next one, we're saying quantity supplied is equal to P. So remember, the C variable is 0, so we left it out. The D variable is 1, so we're saying 1 times P. Well, we left it out too because it's 1. So we're just saying QS equals P. So whatever the price is, the quantity is the same thing. If the price is 348, the quantity is 348. So again, the math on that, we're saying, okay, well, 1, which is the slope, we don't see it there, but it's there. So 1 times the price divided by the quantity. Well, if the price and the quantity are always the same, they're always going to produce 1 when you divide one by the other, and 1 times 1 equals 1. In the third example, QS equals 2 over P. So again, the slope of 2, and we have price of 10 over a quantity of 20, so 2 times 0.5 equals 1. That's shown 10 and 20 there, or 20 and 40 there. So 20 divided by 40 again is 0.5, so 2 times 0.5 is again 1. Finally, I think probably you see the logical progression. If we have a supply curve start from the x-axis, the PES is always going to be less than 1. So if it starts from the y-axis, the PES values will always be greater than 1. If it starts at the origin, PES values will always be 1. If it starts from the x-axis, they'll always be less than 1. That is, they'll be price inelastic. Again, we can see that pretty easily with math. This is your standard, the first PED formula you use, but in my opinion, the least useful. All I've done, I've kept the same slopes so that you can compare them back to the previous ones, but now we have a positive C value. Again, all that we're getting there when we do the math, We get, with the blue, we get 50% over 100%, so that's going to be less than 100. It's a small number over a big number. Please feel free to check my math. The middle number, 5 plus P equals 66% over 100. Again, smaller over bigger, so it's going to be a decimal, or 80% over 100, smaller over a bigger, that means a decimal. You do notice that the PED values are going to get closer and closer and closer to 1, so our PED value of the first would be 50 over 100 or 0.5, so that would be there, then 0.66, and then 0.8. So you do see them start to approach 1, but no matter what, if we have a positive C variable, no matter what, we're not going to get a value of 1, we're going to get something smaller than 1. Now that you can easily look and see, okay, here's what the PES values are going to be, let's quickly talk about the determinants of PES, why a different product would have different characteristics for PES. Our 4 determinants, the first is time to respond. So this means how quickly can you take your factory or whatever it is that you're using to produce, how quickly can you start producing more? Or a different way of looking at this is how quickly can people who aren't producing the good start to produce that good? So for example, if I make bicycles and the price of tricycles goes way up or unicycles goes way up, I can probably convert my bicycle factory to a unicycle factory pretty easily. If I make prom dresses, it's hard for me to convert my prom dress factory to a unicycle factory. The machines are different, the people maybe don't know how to make bicycles. Anyway, you can see it would take longer. So time to respond can be very important. I kind of started to talk about the second, and this is the convertibility of factors of production. So looking at land, labor, capital, and entrepreneurship, maybe a little bit less so. But when you look at land, some land isn't convertible to multiple uses. It would be hard to use a mountain for much more than snow skiing, right? It would be hard to use a mountain to, I don't know, build a shopping mall on or something like that. It wouldn't be very conducive. Likewise, if we're talking about factory space in a densely packed city, it would be hard to start using that factory space to produce agricultural materials or something like that. An interesting thing to look at for factors of production, especially as it pertains to agriculture, and you'll do an assignment on this, is things such as climate. So if you're in a climate where it's really easy to produce one type of good, maybe bananas, wink wink, well, bananas take a hot and relatively rainy climate, so you're not going to be able to convert that over. If you've got a dry climate, you're not going to be able to start producing bananas if the price of bananas goes up. Okay, unused capacity. This is, many factories don't really operate at full capacity. They could run for more hours. Maybe they are open, maybe they produce for 10 hours a day, and it would be easy for them to produce for 12 or more hours a day. So that's all that one means. And then finally, storability means the product that you're looking at, the product that you're supplying, can it be stored? Because if it can, if the price of, maybe you have a bunch of, you have a bunch of shoes that you made 5 months ago, and the price wasn't quite high enough, so you just kept them in storage. And now the price of shoes has gone up, so you can easily increase the amount you're supplying, especially in the short run. SR here means short run, so in the very near term. If you've got something different, if you've got cheese, well, cheese doesn't store as well. So if the price of cheese goes up, you couldn't have stored your cheese and then released it now. So you really can only do what you're doing right now.